We're working on section 1.5, which is infinite geometric series. So the word infinite means it goes on forever. I'm going to get you to look at these red parts over here. So if I went 2, 4, 8, 16, this is a geometric series because there's adding. And look, we go 2, 4, 8, 16. So the rate is 2. And if you kept going forever and ever, as long as you can remember, you're going to keep getting bigger and bigger and bigger. Okay? That is called a series that goes on forever. That's called divergent. The sequence does not approach a fixed value. But what we're going to look at is when things are convergent. So if you go 1/2 plus a quarter plus an eighth plus a 16th, we keep getting tiny, 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 and near the end it's going to be like we're adding 0. Okay? So when it's like we're adding 0, it's going to approach a value. And that's what we're going to be able to find out. Okay? So, couple things we need to know. To converge on something means to approach it. An infinite series is convergent if the sequence of partial sums approaches a value. If an infinite geometric series is convergent, the value of the combination is a proper fraction between -1 and 1. This is really important. That's how we're going to decide if it is a convergent ratio. So if it's between -1 and 1, so if we have -1/2, if we have +1/8, if we have 3/7, all of those are between -1 and 1. So if that ratio is one of those things, this will converge. To find the sum, we're going to use this formula. And just so you know, that means S infinity, the infinite sum. If I made this series go on forever, this geometric series go on together and add it up, this is my answer, S infinity. Okay? It equals term 1 divided by 1 minus R. Okay? Are we ready? I think we're ready. Okay. So it says here, decide whether each of the if these are infinite geometric series, is convergent or divergent. State the sum. Okay, first thing we have to do is we have to look at the ratio. This is 1 over -1 over 0.5, or -1 over 1/2. That is -2 is the ratio, right? Because if we go 0.5 times -2, we get -1. Times -2 is +2. Times -2 is -4. So R equals -2. Looking back at our key ideas, I said that in order for it to be convergent, it had to be between -1 and 1. That is not between -1 and 1, so it is not convergent. This is divergent, meaning it's not going to approach something. It's going to go really, really big, really, really small, or alternate in between. Let's look at the next one. 12, 3 3/4, 3/16. So let's look at the ratio. It's 3/12. 3/12 can be reduced to 1/4. 1/4 is between -1 and 1, so this is convergent. As soon as we identify that it's convergent, we have to use the formula to find out what that sum is. Okay, so term 1 is 12. The rate we said was 1/4. The series is convergent because the rate is between -1 and 1. To find the sum, we substitute the known values. T1 is 12, 1 minus 1/4 on the bottom, 1 minus R. Okay, so they have 12 divided by 3/4. Fraction rules, when you divide by a fraction, you kiss. Look, there's two little things kissing, how romantic. And flip, kiss and flip. Okay, 12 times 4 divided by 3. I'm going to reduce first. So I get 4 times 4, and I get 16. The number one mistake you are going to make in this section, you guys aren't, but lesser mathematicians might make, is that you are going to take R equals what a rate that doesn't fall into the categories, that isn't between -1 and 1, and try and use this formula, and you will not be correct. Okay, so you're going to try and force something that doesn't belong into this formula we used. Try another example here. In the first month, an oil well in Manitoba produced 36,000 barrels of crude oil. Every month, it produces only 95% of the previous months. So we're starting to use up the oil. Write the series of terms that represents this. If the trend continues, what will be the lifetime production and what assumptions were made? Okay, so the series is 36,000 and the next term is going to be 36,000, 1, 2, 3, times 0.95. Then we're going to take that term and times it by 0.95 and continue on. Okay, so I'm going to need a calculator. So I'm going to go 36, 1, 2, 3 times 0.95. And I'm going to get 3, 4, 200. 3, 4, 200. So I have 3, 4, 200. 36,000 goes there. They already did the next term for me. Where's my calculator? Let's check that they've done that correctly. So I'm going to times this by 0.95 will get me my next term. 3, 2, yep. Oh, why do I have too many zeros? What have I done? Let's start over. Okay. 36 times 0.95 equals, okay, that's right, times 0.95. There we go. That's right again. And we'll times it by 0.95 one more time. We get 3865.5. Okay. So what we're going to do is we're going to add this together because I want to know in total. This is how much it made the first month, the second month, the third, the fourth. I want to know how much it makes in total. So how much if I added it up forever. Okay, the reason I can do that is because this is convergent, because the R, which is 0.95, is between -1 and 1. Okay, so I can do this. So term 1 is 36,000, and the rate is 0.95. The lifetime production of the well is equal to the sum of the series. Substitute the known information in. So they already started, they put 36,000 here. Then we go 1 minus 0.95. So that's just going to give me 0.05. And now it's just simple work. 36,000 divided by 0.05, that'll give me my lifetime. 36 production divided by 0.05. And I get, come on calculator, 720,000 barrels. 720,000 barrels. That goes there. Okay, the next thing I said, what assumptions were you making? So this calculation assumes that the well will always produce 95% of the previous month, not more or less, which is probably unrealistic. At some point, the company will shut down operations because it no longer makes financial sense to continue. So at one point, they're going to be making so little oil that it won't even be worth paying their employees. And if you think about it, oil is not always constant 95%, 95%, 95%. We've made some assumptions there. Okay, with you guys, I'm going to show you this where we do a repeating decimal as a fraction. This is really important, so we're going to do this together in class. But other than that, I think you guys are ready to go.